Hi, everybody. Welcome to this episode of not really lectures with Liddington, which is what we do in biology, but I guess conversations with Liddington. I'm here today to discuss some of the issues we're having in math, and this concept that there's a big gap in achievement in mathematics, especially. You've got high flyers, and you've got kids that don't want to get off the ground and can't get off the ground and not flying at all. And it would be amazing if we could close in that gap. So I'm here to talk about different strategies that we can use to do that, right? To be able to help close that achievement gap. And the first thing I'm going to start off with is throwing a shout out and a shameless plug for a textbook that really brought me here to you guys and to this discussion. And that is a text called Mathematical Mindsets. And it is written by Joe Boler, Boaler. If you are a teacher of mathematics, I highly recommend that you get this text. It is filled with so many resources and options and activities that can just elevate your teaching practice and really elevate the achievement of your students. So if you're looking, if anything that we talk about here really jives with you, is something that interests you, I highly recommend that textbook. Because it's just filled with so many things that can really help elevate you and your students. The first thing I want to discuss, I'm going to kind of go two different directions here. And one of those is discussing tracking. So here in district, we have a lot of tracking in math. It's the highest tracked content area within our building. Buildings, plural. In February, I was having conversations with my students in bio about, okay, well, what should I take next year? And, what level? Should I take honors? Should I take academic? Should I take conceptual? And oftentimes we go to math and say, oh, okay, well, where are you in your math track? And in the process of these discussions, even though we have 3 tracks in bio and 3 in chem, there's like 5 or 6 different tracks that a 10th grader could be on in math. And it's wild to see that. And that's one of the things that's sort of an area of opportunity is tracking. We've been doing it forever. But is that the right way? And the more and more we look into it, the more and more research we're finding that says, no, that's actually not the right way to do things. That this tracking is actually hindering our students' achievement in math, and especially in math. And one of the biggest problems with this that Boler talks about in her textbook is having a fixed mindset. That a lot of times when you get shoved into a track, your brain is saying, oh, well, that's all I'm ever going to be. So if you're in a low track, you're in this like sort of autopilot of well, I'm in practical bio, so I can't do anything in bio. When in fact, that's really not true. You might be able to go forward if you bring yourself, your whole self, and your best self to it. But sometimes just being put in that lowest track is giving you that message of, well, that's all you're going to add up to. For us in bio, it's practical is the lowest track, but there are students over in math who in the same grade are taking Algebra 1A. But I also have kids that are already took geometry. Oh, okay, so where is this discrepancy? How did we get to so many different levels and so many different tracks and all this different stuff? And it's really not that. There's a lot that's saying it's not great. I've talked to kids that are in the highest tracks for math and science and English and social studies, and they're taking all these honors and all these APs. And some of those kids have that same fixed mindset going, huh? But it's obviously saying the voice in their head saying something different. Oh, well, I have to, it has to be easy. It has to be easy. Well, no, it shouldn't be easy. It should be challenging. It should always be challenging. And some of those students I found in my experience have the hardest time accepting openness, right? Like that there isn't just one answer to things. Well, did I do it right? I don't know. Did you? So I think this tracking is really sending a fixed mindset message to all the levels of kids. Here's your box. You're an honors box. You're an academic box. You're an algebra 1A box. And there are no boxes. Get out of the boxes. There's a lot saying that's not a benefit. Other researchers are showing that this actually is messing with equity. It's really decreasing the equity opportunities in our buildings. Beaton and O'Dwyer did a study, and they were looking at different countries, and they found here in the US, we have one of the strongest correlations between socioeconomic status and achievement in math. So our lowest SES kids have our lowest scores in math, and our highest SES kids have the highest scores in math. And there's this really distinct correlation there, much higher than there are in other countries, which is incredibly unfortunate. It's also causing decreases in number of participants of different races and different genders. Look around, and as a science teacher, I see a distinct differentiation with who's in the honors classes and who's in the academic classes. Some of that's, might be behavioral. So a kid who is acting out is not getting put in the honors, even though they could be there. But sometimes it's just a mindset. It's, well, girls don't do science. Yeah, we do. Girls are in STEM, all levels of STEM. Let's represent. But this tracking is kind of shoving that fixed mindset down our throats again. And there's also other studies that are showing that sometimes this tracking leads to kids tailing off of those higher level tracks. They get burnt out. They get frustrated when they get shoved into a situation where all the kids are smart. If they're not the smartest cookie, they've been used to being the smartest cookie all the time. Oh no, oh no, oh no. Look at all these other people around me. Sometimes that gets frustrating, and with that fixed mindset, they're just going to hop right off that high-level math train. And that's incredibly unfortunate. Now, talking about detracking is a whole conversation that would take district-wide initiatives, which is something that we're not going to be able to do. So, okay, Mrs. Liddington, what can I do in my classroom to help close these achievement gaps? I might not be able to change the tracking system, but I can change what I do. I can change my practices and my behaviors and what I do with the students in front of me. Well, here's a couple of things. Believe it or not, homework is not good. Sending home worksheet after worksheet after worksheet after worksheet is just making us bored and memorize stuff. So if we're going to send homework, it's got to be meaningful. So if you've got Joe Bowler's mathematical mindsets and you flip to page 53, there is an awesome resource, homework reflection questions. And it gives a list of reflection questions that you can send home with kids to answer at home and then bring back and start a discussion the next day. And instead of them just banging out a bunch of problems, they're thinking about the material, they're reflecting on it, they're summarizing in some way, they're analyzing, they're making a connection, they're accessing those higher level thinking skills with the material in a way that feels more meaningful than just pounding a bunch of problems down their throat. So that's something that can easily be changed in one classroom is that model, and changing the homework initiative within your classroom can make a big difference. Because honestly, who's doing the homework? Your highest achieving kids who they don't need to do 1,000 more problems, right? But if you make every kid go home and answer one question that's a reflective question, you're more likely to get kids on board, right? If you only have to, I only need one homework question, awesome. That's pretty doable. And then even if they don't really reflect until you start and you come back and you're like, oh shoot, I forgot my homework. It was one question. You can probably sit and reflect there in a little think, pair, share or something like that. So you can still engage those kids that might have forgotten their homework. Another huge thing that a lot of research is showing, Bowler's talking about it a whole bunch, is collaboration and the power of collaboration. Being able to work in a group is so helpful, because if you hit a problem and you're struggling, but you're doing it by yourself, you're even more likely to get that sort of like that fixed mindset message. Oh no, I'm struggling. I'm failing at this. I don't like this. But if you're sitting and working with a partner or two, that burden kind of comes together, right? If everyone's struggling, phew, right? Okay, well, they don't get it either. Okay, well, now how do we figure this out? And that mentality of, okay, now it's teamwork. Now we got to work together to figure this out, makes it feel less daunting. It's one task that those multiple people can attack. This can be group work activities, or this might even be possibly like a buddy system. You could do a buddy system. Go work with your North buddy, your South buddy, your East buddy, your West buddy. And those buddies can be kind of purposefully chosen based off of what you're trying to get out of the activity. Compass buddies, it's like a way of picking buddies. So you could do something like that. But another task or activity, I guess, that you can do to try to increase this engagement and sort of close off those achievement gaps is to make things open. When you have students just plug and chug and do the same thing over and over again, there's one task, there's one direction through to the information, and it's not engaging and it doesn't allow that openness. So math is not just 1 + 1 is 2. It's a process. It's how do you get to the answer? And the more we make math rote memorization, the less kids understand just how powerful math can be and how creative of a process we can make it. So increasing the number of open inquiry-based activities, because allowing kids the flexibility to get to the answer, whatever direction clicks for them, is really powerful. It's engaging. It gives kids that voice and a choice to think of things the way that works for them. If they have to memorize, this is the process that I take, well, it's like a GPS, right? If you're driving to school, there's not only one way to school. You might have a blockage the way you usually go. You have to go out and around. So you still have to be adaptable. And that's how the brain should be able to work, is move on the pathway that makes the most sense for that particular learner, like the direction that makes the most sense for that particular driver. And so when we give students these big open inquiry tasks, or even a choice in tasks, if you're trying to do areas of two-dimensional shapes, let kids find as many rectangles as they can with an area of blank, or find as many triangles as you can with an area of blank. And then that way kids, I don't really, okay, I can do that one better. I can do that one better. All right, let me take that one. So then they're taking the path that they feel they're going to be most confident on. And because they feel they're going to be confident, they're more likely to make it to that and continue on down that pathway. So what does this look like? If I'm in a classroom, cool, Mrs. Liddington, you're telling me these different strategies. It's really awesome. But can I get some help in some options and some opportunities and some ideas? One of them, I'm going to take you out to this website. It is Joe Bowler's website, U-Cubed. It's tons and tons of resources for different activities. So this particular activity is called pennies and paper clips. I don't know why that word was so hard for a minute there. It's called pennies and paper clips. And essentially, kids would get put into groups. They have this little checkerboard. They're given 2 pennies and a big load of paper clips. And then they have specific instructions of, you place your 2 pennies. Here are the directions where you can place paper clips. Go. And the kids have to figure out how to win the game. So they've got limited materials. They all have those same materials. They have the same board. They have the same directions. And each group is going to come to the conclusion in a different way. They are all thinking with a mathematical mindset. They have to be strategic. They're collaborating on this, but it's a big, open, inquiry-based task that the kids have to kind of figure out, right? And a lot of times that's what math is. Kids don't understand that it's like this organic figuring out of things. Kids just think it's memorizing. Boom, 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 boom. There's so much more to that. It's much more beautiful than kids even realize that it is. Another little video. I'm going to show you this video too of a number talk. This is Joe doing a number talk, and number talks are an amazing thing for kids to be able to see and just talk about their thinking. Because as you'll see in this clip, we all think about things in completely different ways. It's the same, might seem small task, but there's so many ways to get to that information. So I'm going to show you this clip and just enjoy watching a number talk in action.
Hi everybody, thanks for working with me today. We're going to do a little math activity where I'm going to ask you to look at a collection of dots. I'm going to flash it up and take it off. And I'm going to do that because I don't want you to count the dots. So I want you to figure out how many there are without counting. Can everybody see this screen? Are you ready? All right, so just all together at first, how many dots did we see? 7. There were 7 dots. So who would like to tell me how they saw or where they saw the 7? Let me put them back on the screen in case we want to refer back to them. Yeah, do you want to go first?
So I saw 3 on the outside, and I was like, oh, that's 6. And then the one in the middle would be the 7th one.
Okay, what's your name?
Bahar.
So, Bahar, did you see it like this?
Yes.
Great, thank you. Yeah.
I saw 3 dots, and then I saw that center dot, and so my brain kind of went, what? Because I was thinking about like the outside, kind of like Bahar was thinking. So then I really quickly just tried to think about it all together, and so I just counted like all of the outside like in pairs.
Okay.
And then I counted the 1.
So these pairs 2, 2, and 2. So I'm going to say you saw it kind of like this.
Yeah.
Is that right? Yeah.
Okay, so I saw kind of like a row of 2, a row of 3, and then a row of 2.
Okay, great. What's your name?
Ellie.
Ellie?
E-L-L-I-E.
E-L-L-I-E. So you saw Ellie as 2, 3, and 2. Great. Yes.
I saw it as lots of triangles.
Okay.
Really weird.
Is this one of them?
Yeah. That's one, and then,
This one?
yeah, and then, yeah, I think you get it.
Great. All right. So you, Jamie, you saw it like as a triangle here There's a triangle here and a triangle like that. Thank you. Yeah.
I saw it as a trapezoid on top and then 2 on the bottom.
Okay. So is it like this, Anisha? This? Great. Thank you. Sophia?
I saw 2 diamonds with the middle one overlapping.
Okay.
But yeah.
Is it like this?
Yes.
Thanks. Yeah.
I saw 2 dots on top and then 3 in the middle.
Mm-hmm.
I saw the shape get smaller.
Uh-huh.
So then I was thinking, okay, it's basically symmetrical. So then there was another 2 dots on the bottom.
Okay. So you saw it a little bit like this, but your thinking of the way you went through it was different. So that's important and different. So you saw these, and then kind of later you realized that was also the bottom. Great. Yeah.
I saw it as 5 dots in the center and then 2 dots on the outside.
Okay. So 5 dots in the center and 2 on the outside. You're going to help me out with this.
So there's like a square of 4 dots and then 1 dot inside that square.
This square.
Yeah, and then there's 1 inside and then there's the 2 on the outside.
Okay, great. That's not very square, but we'll pretend. And a dot there, like that. Great. Did anybody see it differently to this, or can anybody see it differently now?
I can also see it as like if you were to cut it from the center diagonally.
Uh-huh.
There's 2 on each side and then 3 on the other.
And is the diagonal you're seeing this one?
Yeah.
What was your name again?
Ellie.
Ellie, that's right. Ellie. So Ellie also saw it in like that?
Yeah.
Did anybody see it differently, Sophia?
So I just saw like the outline of the
Mhm.
and I saw, I knew it was like symmetrical.
Mm-hmm.
I just did that thing and then I copied it. So 3 times 2 is 6 and then plus 1 is
So-
6. So pretty much the same thing that Bahar did.
Like this,
Yeah.
but then because of the symmetry you flipped it over. So it looks the same, but your thinking about it is a little different. So I'm going to do it like that. Fantastic. Does anybody have a different way of seeing it? Yeah, Charlotte.
I see it as dots going down the center and then dots on the outside.
Okay. So rewind a bit for me.
So it's like-
Start again. Dots down the center.
Dots down the center, like
Mhm.
those 2 lines, and then there's dots on the outside.
Okay. So this is the center, and these are the dots down the side. Great. All right. So this is kind of the center dot.
Yeah.
Is that right? And
There's
then
lines, and then there's dots on the outside.
those. That's it? Great, thank you. So thanks everybody for doing this with me. The reason I wanted you to see this is math is such an open, visual, creative subject, and you can see here there were so many different ways that people saw just a collection of 7 dots, and I think that's a lovely thing about math. A lot of people think math just has one way of doing it and one solution, but really everything, even just the numbers in math, can be seen in so many different ways, and I think that's really lovely. So thanks very much for working with me.
So I really like that activity. That's just a sample of a number talk. There are so many different ways that we can engage our students in conversation about their thinking and all of the different paths that they take to their thinking. There's so much. As Joe said, it's this open and creative process that math is, and we never think of it that way because we're not taught that way. So as teachers, let's switch it up. Let's try to help our kids see just how beautiful and creative of a process math can really be. So some of the sources that I used and talked about in this discussion, not a lecture with Liddington. So I hope you have been inspired to really help close that achievement gap with our students. Just some different strategies that we can use to elevate their achievement, especially in math, an area that is so divided in its achievement. It would be wonderful to see us as a team come together and shave that gap down.